digital era, the problem is no longer the lack of choices. The real problem is having too many. Assalamualaikum warahmatullahi wabarakatuh. Hello guys, and welcome to our last project presentation. Today, we, the Group 5, want to present our project, an AI-based movie recommendation system designed to help users navigate massive content libraries and discover movies that truly match their preferences. Next. Alright, this project is a collaborative work developed by Group 5, consisting of Jenny Agustin, me, Zaki Helmi, and Nico Haikal Javier. Each member contributed to system design, algorithm analysis, and conceptual development, ensuring that this project is not only functional but also academically grounded. Next, we want to explain to you the problem description that will be presented by Jenny. The floor is yours.
Okay, in this time I would like to explain about the problem description. So the development of digital technology has transformed the way people enjoy movies, shifting from cinemas to streaming platforms such as Netflix, YouTube, or many more. And these platforms provide thousands of titles across various genres. But however, the vast number of choices often makes it difficult to users to decide what to watch according to their preferences. To address this issue, an artificial intelligence or AI-based recommendation system is needed, one that can tailor movie suggestion to users' interests and viewing habits based on their watch history, ratings, and preferred genres. So this study examines the method for developing a movie recommendation system capable of providing personally relevant recommendation, but thereby reducing search time and increasing user satisfaction. And these are the purpose and the benefits of this system. The purpose to develop an AI-based movie recommendation system that analyzes user preference and behavior, and apply the content-based filtering method to recommend movies with similar content, improve recommendation accuracy using IDIF and cosine similarity, optimize user experience by providing fast and relevant recommendation, and the last purpose is enhance user satisfaction and retention on the streaming platform. And these are the three benefits that can impact to three components. For the first one is user. It can help find movies that match their interests and habits, save search time, and enhance comfort and satisfaction when using the platform. And also for the platforms that we can increase user loyalty through personalized recommendation and optimize content promotion and visibility. And for the last one is for the industry film to expand the reach of movies to target audience and promote the overall growth of the digital entertainment industry. And the next we will talk about data types, and these data types will be explained for Zaki.
Alright, thank you, Jenny. In this system, we have several data types and sources. This system relies on structured movie data, including the movie title, genre, release year, director and main cast, synopsis, ratings, and keywords. Well, these attributes form the foundation of content understanding, allowing the system to analyze similarities between movies and users. Next. To improve efficiency, we apply key-means clustering and unsupervised learning algorithms. The goal is to group movies based on feature similarities such as genre, rating patterns, and thematic elements. By clustering movie first, the system reduces computational complexity and speeds up the recommendation process, especially when handling large-scale datasets. Well, And in this stage, we use k-means clustering, which is an unsupervised learning method. The main idea of k-means is not prediction, but organization. The algorithm group movies into cluster based on similarity in features such as genre, rating patterns, and etc. that I already said. And by doing the system, discover hidden patterns in the data without predefined labels. The practical impact is efficiency. Instead of comparing a user with every movie in database, the system only search within relevant cluster. So the cluster is based on the user behavior and the historical data based on the user search, the user preference in movies, preference maybe this director and etc. This significantly reduces computational complexity and makes the recommendation process faster and more scalable. Next. The core strength of our system lies in its hybrid recommendation approach, which combines two main powers, collaborative filter and content-based filtering. The collaborative filtering is learning from user user item interactions, while the content-based filtering is focusing on movies attributes and user preferences. This integration helps overcome the cold start problems where new users and or new movies lack sufficient interaction data. Next, we would like to explain to you our AI conceptual flow that will be presented by Nico. The floor is yours.
Okay, let's show the overall conceptual flow of our AI-based movie recommendation system. It describes how data move from the user through the AI process and finally back to the user as personalized recommendation. Each step is connected, forming a complete cycle from data input final output. Next, the first stage is the system is data input. At this stage, the system collects use data such as viewing history like movies, rating, and favorite genres. It also collects movie data including title, genres, actor, director, duration, release year, and synopsis. This data becomes the main foundation of the AI system. The better data quality, the more accurate the recommendation will be. After that, the system performs clustering. Clustering is the process of grouping movies based on similarities. We use algorithms such as k-means to group movies by feature like genres, actor, and rating patterns. The helps organize the data meaningful group and makes the recommendation process faster for efficiency. Next, the next step is the movie database. This data store all movies that have already gone through the clustering process. Each movie has cluster label and becomes the main source of information in the system. The database can be updated regularly when new movies are added. Then we move move to the algorithm process, which the core of AI system. Here the machine learning model analyze the relationship between user preference and movie characteristics. It apply content-based filtering methods such calculate similarity based on genre or description. This process help the system find patterns that decides how relevant is movie for the user. Next, in the generate score stage, the system calculate the higher the score, the movie will become recommend. The system will be method such and percent correlation and measure similarity. The score then used to rank the recommended movie. After that, the results are shown in the visualization interface. the interface present the recommendation is a user-friendly way, such as movie list, pattern, or interactive display. It applies the concept of human-computer interaction, making the system easy to use understand. Next. Next. This is where you can directly see the list of recommended movie, read description of watch them is the final output stage of AI system. The system also another recommendation. If is select yes, the system will calculate the data and generate recommendation. Is the user select no, the process will stop. The system continue learning from use user behavior to improve future recommendation. Finally, and process marks the completion of one recommendation cycle. The system step after the result are show the user does not request another recommendation. So that's the overall flow of our AI recommendation system. Next, my teammate Zaki.
All right, thank you, Nico. Well, that's all. That's the AI flow or the conceptual flow, the overview that has been explained by Nico. Next, I would like to explain to you the more, the least, the last but not least, the potential biases and errors. Well, we all know that no AI system is free from limitation, including our system, the AI recommendation film. The common challenges that we face are datasets imbalance favoring popular films. Well, popular films are often make datasets in our system be imbalanced, and then overfitting, reducing generalization, and then we have noisy or fake ratings. Well, fake ratings also can imbalancing the database dataset that will be a biases in our system, and then we have cultural and representational biases, and also the last is confirmation bias creating filter bubbles. Acknowledging these issues is the first step toward responsible AI development. Next is conclusion that will be explained by Jenny.
Okay, so after all this explanation, we have four conclusions. For the first one is an AI-based movie recommendation system helps users discover films that match their interests and viewing habits without need to manual searching. For the second one, a hybrid approach that combine collaborative filtering, content-based filtering, and clustering make the recommendation more accurate, personalized, and efficient. The third one, this system helps overcome information overload on streaming platforms while increasing satisfaction and loyalty. And for the last one, with further development such as context integration or rich data or explainable AI for transparency, the system has the potential to become an innovative solution in the digital entertainment industry.
In the end, artificial intelligence is not about making decisions for people, but about helping people make better decisions. This project shows how data, algorithms, and human preferences can work together to create recommendations that are not only accurate but meaningful. Thank you for your attention, guys, and see you in the next time.